Actually, this question can be done by geometrical method and mathematical method both. But I always prefer to use geometrical methods because geometrical methods are usually short also, and mostly in geometrical methods from the very beginning we know our way of proceeding. But in mathematical methods many times we have to start solving and proceed according to the situations which are arising. Hence, I always prefer to use the geometrical methods. In this question, he is saying that if Z1 and Z2 are complex numbers such that real part of Z1 is equal to mod of Z1 minus 1, real part of Z2 is mod of Z2 minus 1, and argument of Z1 minus Z2 is pi by 6, then imaginary part of Z1 plus Z2 is equal to. Because Z1 satisfies this condition, Z2 satisfies this condition, what it means? It means that Z1 and Z2 satisfy the equation real part of Z is equal to mod Z minus 1. First we check this equation represent which curve. Again, further I can proceed geometrically and mathematically both, but again I will prefer to go geometrically. Keeping in mind that real part of Z, that is equal to x if Z is x plus yi, represent the distance of Z from y-axis. That is, if this is the point x plus yi equal to Z, x is this much, y is this much. Hence, thinking geometrically, we can easily say that the locus of Z will be a parabola because the given information means the distance of Z from 1 plus 0i and distance of Z from y-axis are equal. That is, if Z is here, one zero is the point on real axis, that is x-axis, and this length is x. That is, Z moves such that this distance is equal to this distance because x means this thing and this means this length. This is real part of Z, this is mod of Z minus 1. The two are equal means the locus of this point will be a parabola for which this line will be the directrix and the point 1 0 will be the focus of that parabola. That is, we can say Z1 and Z2 both lie on a parabola with focus at 1 0 and directrix as y-axis. Now I tell you the geometrical meaning of argument of Z1 minus Z2 equal to pi by 6. Remember that if A is a point having fx Z1, B is a point having fx Z2, and this is AB vector, and I produce it backward, and this angle is say 40 degree. In the language of complex number, we write it as argument of AB vector is equal to 40 degree. That is, argument of Z2 minus Z1 is 40 degree. Hence, argument of Z2 minus Z1 is equal to 40 means the vector AB is making an angle of 40 degree with positive direction of x-axis. And keeping this information and this information in mind, we can surely say that the figure form will be of this type, and this means argument of BA is pi by 6 where Z1 is the complex number of A, Z2 is the complex number of B, and Z1, Z2 lie on this parabola also. Therefore, the figure formed will be of something of this type. B will be here, A will be here, Z2, Z1. That is, this figure satisfies all the three conditions. And this information means B vector is making an angle of pi by 6 with positive direction of x-axis. Agreed, there are infinite number of lines which make an angle of pi by 6 with positive direction of x-axis. For example, all these lines. And now imaginary part of Z1 plus Z2 means sum of the y coordinate of A and B. That is, I can say imaginary part of Z1 plus Z2 means y1 plus y2. And now I am going to tell you a property of parabola which I am going to use in this question, and that property says that if this is a parabola, these are the parallel chords, then the midpoint of all these chords always lie on a line which is parallel to x-axis, and the equation of this line is y equal to 2a upon m, where m is the slope of these lines. Note that these points are midpoint of all these parallel chords. It is also clear from this parabola that even if the parabola is of this type, that is, vertex is not at origin, it is somewhere afterwards, even then, if these are parallel chords, the midpoint of all these chords will lie on a line whose equation will be y equal to 2a upon m, where m is the slope of these chords. And because each one is midpoint of a corresponding chords, hence if this is y1, this is y2, then I can say y1 plus y2 by 2 will be equal to 2a upon m. That is, y1 plus y2 will be constant if the slope of chords are same, as we have already proved that the locus of z is this parabola with focus at 1 0, directrix as y-axis, and these are the parallel chords, and z1 is somewhere here, z2 is somewhere here, this point is a, this point is b, and as it is given that argument of z2 and z1 is pi by 6, and now keeping this conclusion in mind that z1 and z2 lie on a parabola with one focus at 1 0, directrix as y-axis, and B is somewhere here, A is somewhere here. This angle is pi by 6. It is Z1, it is Z2. Given information clearly shows that Z1 and Z2 are any 2 points on the parabola. Only condition is argument of B at is pi by 6. That is, this line always make an angle of 30 degree with x-axis. According to this property, y1 plus y2 by 2 will be surely equal to 2a upon m, where m is the slope of these chords, and parabola maybe here also, maybe here also, makes no problem, because if I shift the parabola anywhere on right hand side or left hand side, this formula will remain same. It is obvious to see. If this is having y coordinate y1, this has y coordinate y2, as I had proved that y1 plus y2 is equal to 2a upon m, hence I can say y1 plus y2 will be equal to 2 into a. How much is a? Because vertex is at the middle point of origin and the line joining focus, hence I can say a is 1 by 2. 2 into 1 by 2 upon m. M is slope of this is 10 pi by 6, 1 by root 3. Hence I can say y1 plus y2 will be equal to 2 root 3.